Identity is a symbolic representation of a person, object, or software. It can be a name, a code, or a number. And when we see that symbolic representation, we will immediately know about who or what it is. For example, this here is a symbolic representation of a person. This would be the name of a computer. This would be a code representing a program instance, and this could be a number that is representing BI program instance. Now, from the perspective of computer, in order for something to be identity, it has to be able to be authenticated and authorized. Authenticate means to verify someone's identity. For example, we can verify identity of a person by using his password, and authorization means that we have a list of all of the permissions that that person has. For example, one person can use all of the tables in one database. Now, when we register such identity inside of some program or software, in that case, we have created an account. So here we can see a table with a user registered inside of Monet database. So this would be his account. And we can see all of this on the example of a library. When a user comes, he can take his library card to authenticate himself. And then in a computer, we have an account. So by using this library card, this account will list all of the permissions that we have, so we can then borrow a book. Now, when we install Monet database, at the start, we have only one user, that is MonetDB user with the password MonetDB, and this is administrator. We can list all of the users and roles in Monet by reading from this system table. So this is a table with authorities or authorizations, and here we can see our administrator, and he has an ID of 3. We can then read from the system table with schemas. So I will read from sys schemas, and here we can see that owner of all of the schemas is actually user with the ID of 3. So that means that MonetDB is owner of all of the schemas, and that means that he is administrator. I will now clear my screen. In order to create a user, we need to provide a username and the password. We will see later how to give permissions to a user. And for now, we just have to be administrators, because only administrators have right to create new users. So I will run this statement here because I'm currently administrator. This will be username of my user. This is his password, and this is his full name. So I will run this statement. New user was created. Then we can read from that system table sys.auths. Here we will find a list of all of the roles and users, and this here is our new user. We can also read from system table sys.users. In this table, we will only see users. So here we can see users, and here we can see users and roles. For example, this here is a role. During this creation of the user, we haven't provided a default schema, and user must have a default schema, and because we haven't provided it, then a new schema will be created, and that new schema will have the same name as a user. So we will create a schema with the name user1, and we can check that if we read from this system table sys.schemas, and here we will find a new schema user1. And I also want to tell you that it is not possible to create a user without a password. I will now clear my screen. While we are still logged in as administrator, we will create one new table with the name schema test. This table will have a number in it. So we will insert one number inside of this table. And because default schema of administrator is sys schema, then we can read from this table by providing this sys schema in the name of a table. So if we do this, we would get our table, and I will also grant select write on this table to user1. This means that user can execute select statement on this table. So I will run this, and after this I will clean my screen. I will now quit this administrator session, and I will log in as newly created user user1. My password is 123. After this, we will check what is default schema for this user. So we will run select current schema, and default schema is of course user1 schema. After this, I will create a new table, and this table will have the same name as the previously created table. So again, I will create a table with the name schema test, but I will not qualify its name. So I will not specify a schema here. So we know that in this case, a new table will be created inside of the current schema. So I will run this. This table will have a letter in it. So I will add one letter. And after that, we can read from our table. I will now provide the name of a schema so that we can be sure that this table here is inside of the user1 schema. So this is our newly created table. I will now change some things. I will first change one attribute of a user, and this attribute is schema pet attribute. Inside of this attribute, we have a value which is a list of schemas. First, we will say that our schema is sys, and then that our schema is user1. So I will change this attribute of our user, and I will also change the current schema. I will say that VOC is the current schema. After these changes, we can test them, and I will now read from the table schema test, but I will not provide a schema. We know that we have two tables with this name. We have one table inside of the sys schema and the other table inside of this user1 schema. I will now run this, but instead of getting this table that is inside of the user1 schema, we will get a table that is from sys schema. And the reason for that is this. When we read from a table with a qualified name, we will first search for that table inside of the current schema. But inside of VOC schema, we don't have a table with this name, so we will skip VOC schema. And after that, we will search through schemas that are listed inside of the schema pet attribute. So we will first search inside of the sys schema, and we know that inside of the sys schema, we have a table with a schema test name. We created that table previously when we were administrator, and so we will get that table as a result. We now try to create a new table. I will create this table inside of current schema, which is VOC. So I will run this, but I don't have privileges to create a new table inside of this schema VOC, so this statement will fail, so we will get an error. So when we try to create a table, we can only create it by default inside of the current schema, otherwise we will get an error. But if we read from a table with unqualified name, in that case we will first search for that table inside of the current schema and then inside of the schemas that are listed in the attribute schema pet. I will now clear my screen. I will now try to delete our newly created user1. So I will drop this user, and we know that this user has a default schema user1. We now try to delete this user. I will get an error because this user owns a schema. So then if I try to delete that schema, we will also see that that is not possible because this schema is a default schema for some user, that is for user1. So we cannot delete any of them. In this case, we have to act in this way. First, we have to change default schema of this user. So I will set sys as default schema of this user. After that, I will delete schema user1. I have to use this keyword cascade because we have a table inside of this schema, and I also want to delete that table. So I will run this, and only now we can delete our user. So this is how we delete a user if we face a problem like this one here. I will now clean my screen. I will now quit from this session, and then I will log in as administrator. My password is MonetDB. We will now create another user, but this time we will define all of his attributes. So I will paste this statement here. So my user has many attributes. we have already saw that this is default schema and this is schema pet. But beside this, we can define maximal memory. This is maximal memory that can be used by the queries run by this user. Queries of this user can only use 6 threads, and his queries will use optimizer minimal fast. Optimizer is used to optimize our queries so that they can run faster, and we can choose between different optimizers. So I will create this new user. Now I will read from one system table. This is system table sys optimizers. Here we can see that we have different optimizers. We have minimal pipe, minimal fast, and so on. But we shouldn't change this. We should always use default pipe. There is no reason to change or to specify optimizer, but we can use and change all of these other attributes. I will now clear my screen. When we create a new user, his password will be encrypted with SHA-512 encryption, and it will be stored inside of Monet. But we can encrypt our password ourselves, and for that I will jump here to this web page. I will type here my password 123, and I will click on generate hash. So I will get a hash of my password. Then I will go back to terminal, and I will run one statement that will use this hash here to create a password for a new user. So I will use this statement here. So we will create user test, but we will provide encrypted password, and this is my encrypted password. So this here is the same as this here. We will also provide the full name of a user and default schema. So I will run this. After that, I will quit this session as administrator, and then I will log in as a new user. But this time I will not provide, of course, this hash. I will provide the original password 123. So I will type here 123, and this is how we can log in. After this, I want to delete this user, so I will again quit this session. I will log in again as administrator. My password is MonetDB, and then I will drop this user test. After that, I will clean my screen. We will now see how we can modify our users. I will first rename our user Sally to Mary. For that, I can use this statement. And after that, I will show you how we can change passwords. Now, each user can change his own password. I'm currently admin, so I can, of course, change my own password. For that, I will use a statement like this one. Instead of using MonetDB as a password, MonetDB2 will be my new password. But I do not want to change a password of my admin, so I will immediately change it back. After this, I will show you how we can change a password of some other user. We are currently admin, so we can do that. So we can run a statement like this one. In this statement, we'll change a password of this user Merrick to be 456 instead of 123. We can also change other attributes. We can change default schema, schema pet, maximal memory, and maximal threads, that is maximal workers. Now, we don't have to change all of these attributes. We can change only a few of them. For example, this other statement will only change 2 attributes. And here I want to show how we can disable this limit on max memory and on max workers. So we just have to type no max memory, no max workers. So I can run this, and by using alter user statement, we cannot change optimizer of a user. At the end, I will read from the system table sys.users, and here we will see that our user has a new username, and we can also see that now maximal memory is 0 and maximal number of threads is 0. That means that there is no limit. I will now clean my screen. Next, we will see again how we can modify passwords, but this time we will use encrypted passwords. Now each user can modify his own password. So I will now modify my password. For that I can use a statement like this one. So first I have to provide my old password, and then I can set my newly encrypted password, and I will provide this SHA value. This is here just a comment, so I'm not really going to change password of administrator, but I will change a password of a user. And for that I will use this other statement. So this is how administrator can change a password of some other user. So we will alter this user Medic, and we will set encrypted password, this one here. So if we run this, we will change his password. At the end, I will drop this user Medic. I will drop here, and I will clean my screen. We will now talk about roles. Roles are named collections of privileges that can be given to some user. And privileges are permissions to do some actions like update, delete, or insert. And instead of giving privileges to a user one by one, we can collect several privileges into one role, and then we can assign that role to a user. We'll now jump here to this web page, and here we can see that in chess we can unite privileges to control white figures in a role that is called white player. Privileges to control black figures can be united in the role with the name black player, and in one match we can take the role of the white player, and in another match we can take the role of the black player. So depending on what role we have taken, we will have different rights. We'll now go back to terminal, and we will see how to create a role. But first I want to show you a difference between a user and a role. So I will create new user, and this user will of course appear in the system table sys.users. So here we will see our user, and this user will not appear in the system table sys.roles, because here we will find the real roles. But if we read from the system table sys.odds, we will also find our user here. So here is our new user, so this user will also appear here. In this table sys.odds, we will place all of the roles and users. So this is also some kind of role, but this is a special role, because this is a role that is created when a new user is created. It has the same name as the user, but this role cannot be given to some other user. This is a private property of this user. On the other side, only roles that are created and that appear inside of this sys.roles table will be grantable to any user. We will now see how to create such role. So I will use statement create role. And this is how we create a role. And this role will of course appear in the system table sys.roles. So here we will see our new role. Here it is. But it will also appear inside of the system table sys.odds. So here we will find both our new user and our new role. But this is a real role that can be granted to anyone, and this is just a role that belongs to this user, and it is his private property. I will now clean my screen. Default role is a role that user will take when he logs in into database. In this users table, we can see a default role for our user, new user. So I will run this, and here we can see the default role has ID that is equal to this number. I will again read from the system table sys.odds, and here we will see which role is this. So this is the role that is default role for this user, and this is the role that was created when this user is created. It is his private role. But we can change that. I can set new role as a default role for this user. And for that we can use alter user statement. So I will run it, and then I will again read from the system table sys.users, and we will now see that this number was changed. So instead of using new user role as a default role. Now we have different number, and this is that different number. So now new role is default role for this user. We can also set default role for a user when we create a new user. I will now create one new user, and among his attributes I will set default role. So I will run this, and if we now read from the system table sys.users, we will see that his new role has this number, and this number belongs to new role because this new role is set as default role for this user. I will now clear my screen. We will now see who is the current user and which is his current role. So I will run this statement, and we will see that we are currently administrator and that his current role is his default role, his private role. But I want to change this. I want to use new role as my role. So I will use a statement like this one, set role, new role. After this statement, I should have all of the privileges of the new role. So I will run this, but this will fail. Before we can set some new role, we first have to grant that role to ourselves. If we are administrator, if we are not administrator, then someone else has to grant that right to us. So I will now grant this right to myself. So I will use this statement, grant new role to myself. So I will run this, and only after that we can now set new role as our current role. So this will now be successful. And if we now read from the variables current user and current role, we will see that administrator now has current role, new role. Now one user can have many roles, and he can jump between them by using this statement. So after each of these statements, he will change his role. So we can now easily go back to administrator's default role MonetDB by using again set role, and now we have changed us back. I will now show you how we can see which roles are available to some user. For that, I will read from the system table sys.user role, and here we will see two lines. This number 3 is ID login of administrator, so administrator can use a new role, and this is because he have granted that role to himself. But who is this user? This is Eminem user. This is the user that we have previously created, and during his creation we set the attribute default role to a new role. So he will also appear here. But one thing is missing. We also have that new user. We alter that new user, so we have changed his default role. But that alter statement will not automatically grant a role to some user so he can use it. So this user, new user, after he log in, he will have a default role, new role, but he will not be able to use it because it is not granted to him. So we have to solve this. So I will, as admin, grant this role to that user. So now he can use it, and we can check that if we now read from the system table sys.user role, we can see now that new user can also use new role, so it will be his default role and he will be able to use it. If we want to delete some role, in that case we are going to use drop new role statement like this, and we can check whether we have deleted our role by reading from the table sys.rows. So here we cannot no more see our new role.